What you just saw was illegal, not the video, the speed. 603 kilometers per hour on the ground. A speed so dangerous, so revolutionary, they can only test it deep in a Japanese mountain tunnel. This isn't just a train. This is a 250-ton metal aircraft with no wings. And it's about to rewrite every rule of travel you know. Strap in. We chase speed. Cars, planes, rockets. But there's a cheat code physicists found. To break the ultimate barrier, you don't push harder. You delete your enemy. Friction. Wheel-on-rail trains are fighting this monster every second. They're strong, but they're losing. Their ceiling? 224 miles per hour. But what if you could make the monster disappear? This is where the rules end, and the future begins. Maglev, magnetic levitation. It sounds like sorcery. Let's break the illusion. Think of the magnets like an invisible dance partner. Step 1, the lift like trying to push two north ends of a magnet together. They refuse. That refusal is your lift. Step 2, the push the track isn't just a path. It's a linear motor. The train is the piston. It's not being pulled. It's being propelled by the road itself. Fact 1, the world's fastest train isn't in service. It's a ghost. It lives in a lab, hitting 375 miles per hour in bursts, waiting for its city-to-city track to be built. Fact 2, cut the power and a maglev doesn't just stop. It becomes a very expensive metal brick sliding on emergency skis. Total system failure is its Achilles heel. Fact 3, that famous Shanghai maglev, it cost over $1.5 billion for 19 miles. For that price, you could buy every single passenger a private helicopter. Why build it? The answer isn't logic. It's a statement. But deleting friction wasn't enough. Engineers saw the next ghost, air. At 375 miles per hour, air doesn't flow. It fights. So, the craziest idea was born. If you can't beat the ghost, lock it out. Enter the VAG train. Or as you know it, the Hyperloop. No air means no air resistance. The theoretical speed limit? 760 plus miles per hour. You could race a plane at cruising altitude and win. Fact 4, that perfect vacuum tube, a tiny crack, a small leak, is like a grenade going off. Air rushing in at supersonic speeds would create a shockwave that could shred the pod. It's not a train, it's a particle accelerator for people. Fact 5, going from 0 to 760 miles per hour in a straight line is one thing. But what about a curve? At that speed, even a gentle turn could pancake passengers against the wall with deadly G-forces. The track wouldn't just need to be straight, it would need to be geographically perfect. So, with all this flashy future tech, why does our planet still run on wheels? Because the ultimate superpower isn't top speed. It's average speed, door-to-door time. The maglev might be faster on paper, but if its station is in the middle of nowhere and you need a 1-hour taxi to get there, you lose. The bullet train slides right into the city center you already live in. Its secret weapon? Backwards compatibility. Unknown fact 6. Japan's Shinkansen's average delay is 54 seconds. A delay so scandalously long, they issue formal apologies. That's not a flaw. That's a cult of precision wheels and rails have spent 60 years perfecting. Maglevs are sprinters. High-speed rail are marathon runners with Swiss watches. This is the real war. Not steel versus magnet, but money versus vision. China builds maglevs as a national trophy, a proof of technological might. California's Hyperloop dream hits the wall of property rights and earthquake faults. Europe upgrades its wheeled network because it's cheaper. But then, a breakthrough. Superconductors that work at warmer temperatures. New materials that cut guideway costs in half. The dream gets heavier. The scale starts to balance. We stand at a crossroads. One path is polished steel, a predictable, efficient future. The other is a silent, floating revolution, a leap into the physics-defying unknown. The fastest train in the world isn't in a museum. It's not even on a map yet. It's on a whiteboard, in a lab, in the mind of an engineer who looked at wheels and said, "We can do better." The question isn't which technology will win. It's how far are we willing to go? The track to tomorrow is still being built. You're the conductor now. Which future do you vote for? Maglev miracle or wheeled wonder? Comment your choice below. If this video gave you a rush, hit like, it fuels our research. Subscribe for more journeys to the edge of what's possible. Until next time, stay curious.